implicit. So like Torsten was saying earlier, everything that we've done up to this point has been functions. All right. So if you remember what a function is, we'll just do it graphically. Function is something where the input only has one output, right? You put in an x value, you only get one y value, essentially. And in grade 10, grade 11, grade 12, whenever you did it, we would use the vertical line test. You remember that? All right, so if you can draw a vertical line and it only hits the graph once, it is a function, okay? So only one output for every input. All right. A relation, so that's a function. A relation is pretty much everything else, okay? So the standard one, he did it earlier today. If you have a circle, you can see if I put in an x value here, I can get two different outputs, okay? It fails the vertical line test. And remember the equation of a circle, we didn't do it this year because of COVID, but basically x squared plus y squared is equal to r squared, all right? And r is obviously the radius. That would be r. But you don't need to know that, okay? So when you have a relation, use implicit differentiation. In other words, when you can't write the function y equals something, okay? So if I have, first of all, if I have y is equal to x squared plus 2, that is explicit form. I'm writing y explicitly in terms of x, okay? But if I have this thing, x squared minus 2y cubed plus 4y plus x is equal to 1, can you solve for y on that one? You cannot, all right? It's going to get really, really ugly. So this is implicit form. Basically, when you have multiple y's with multiple exponents, you can't solve for the y individually. You can't write y equals something. Okay, so we have to, when you have that, you need to do implicit differentiation. Okay, so you must use implicit differentiation. Okay. So if I ask you to do this derivative, the derivative of x squared with respect to x, what's the answer? 2x, right? Does everybody agree with that? When these match, when your variable of integration, which is the dx, it's saying take the derivative of this function with respect to x. Well, it's written in terms of x, so we just do regular derivative rule. So we drop the exponent down, take one away, it works. So when these match, it's a regular derivative. But if they don't match, so like that, then you have to use implicit. So does anybody know what the derivative of this is? Yes. So there's two functions here. People see two functions. You see the y, the power of 2, and there's a y. So you have to essentially use chain rule on it. So drop the 2 down times y times the inside derivative. What's the derivative of y with respect to x? dy over dx. That's it. We don't know what it is, so we just write dy dx. It's the derivative of y with respect to x. That is the answer. Okay? Hey, yeah. Sorry. Yes, well, this isn't even an equation yet. We're going to get to equations that you have to solve for it. I think Torsten did a bit of that earlier. So yes, essentially you take 2 times y and you multiply by the derivative. As a what? Yes, when we get into differential equations, you would multiply the dx to the other side and do stuff like that. Okay, but this isn't an equation yet, so. And that's like, we might do that near the end of this course. So. Okay. What if you have this? Okay, before you do anything, what rules do you think you want to use here? You're going to use product rule, right? Because there's two functions being multiplied. There's x times y squared. So product rule says, they're not there anymore. The derivative of the first one. Okay. So what's the derivative of x with respect to x? Just 1. You can use your regular rules. So it's 1 times y squared plus the derivative of the other one. So I'm doing the derivative of y squared. What do I do? 2y. And then what's the derivative of y? dy dx times what? X, the other function. Okay? I know it looks weird. All right? Now, Torsten said you can do this. He doesn't like it. And it doesn't really make sense when we do related rates. But I find that a lot of students, this makes more sense. Or it's just easier to read. So it'd be y squared plus 2y. Instead of writing dy dx, you can write y primed. But like Torsten said, it's easy to mistake that y primed or forget to write that y primed, right? And then you're going to end up with y squared and it's going to be all wrong. So this is the preferred method, but that looks a little cleaner. Okay? Are we okay with that? All right, now we're going to do equations. So, not number 5, number 4. Please find y primed, or I'll say dy dx, sorry, for this relation. I want to know what the derivative of this is with respect to x. So can I use my regular rules? You have to use implicit, right? Because there's multiple y's with different variable or different exponents. All right, so we just go through and we do the derivative. So what's the derivative of y cubed? 3y squared dy dx. Plus, what's the derivative of y squared? 2y dy dx. What's the derivative of negative 5y? Negative 5 dy dx. What's the derivative of negative x squared? Negative 2x, right? That one you can use the same rules because we're integrating with or deriving with respect to x. And what's the derivative of 4? 0. All right, we're not done. Because what are we trying to do? I want to solve for dy dx. So what do I need to do here? Sorry? Factor out a dy dx. Because it's common in this one, this one, and this one. Okay? So I can pull it out of there. I'm left with 3y squared plus 2y minus 5. This negative 2x here, I can move to the other side. So it becomes positive. And then what's the last step? Divide off everything in the brackets. So you get dy dx is equal to 2x 3y squared plus 2y minus 5. And that is your derivative. Okay, is that okay? All right, I'm gonna do one more. So x squared y minus y squared x is equal to negative 2. What is the derivative? Need to write it down. All right. As soon as I get one like this and I see minus 2 terms being multiplied together, I would always, you don't have to, I would always bracket those 2 terms. Okay? Because inevitably somebody will have a sign error when they do this question. Okay, and I'll show you why when we start to solve it. So let's deal with the first, dx squared y. Start on the left. What's the derivative? What rule am I using on this? Product rule, because it's 2 functions being multiplied together. So what's the derivative of x squared? It's 2x times y plus, what's the derivative of y? dy dx times x squared. So this bit, that is the derivative of x squared y. Okay? Then I have to do the other part. Minus. Now we're going to do the derivative of everything in here. So what's the derivative of, what rule am I using? Product rule again. So what's the derivative of y squared with respect to x? 2y times dy dx. Because it's got brackets there, bracketed in this part here. I'll do it in red. 2y dy dx times x plus, what's the derivative of x? 1 times y squared equals, what does it equal? 0. So this is sort of like the chain rule in that things get bigger and then we got to simplify them down. Julia. Because this is product rule, and inside here is product rule as well, right? This negative's on the outside of the brackets. Does that make, do you know what I mean? Because product rule says. Yes. It's plus the derivative of y, which is dy dx, times the other function. Okay. All right. Now, this negative gets dumped into these brackets. Oh, sorry. No, you can put the y after the dy dx if you wanted. Yes. Any other questions? Here? This? Because this bit, so this, here's product rule, right? F times g, if I'm doing the derivative, it's f prime times g plus g prime times f, right? So this, if I call this f and that g, that's f prime times g plus that would be g prime times f. I'm just using product rule just on this bit right there. Okay, does that make sense now? Anybody else confused about that or any questions about that? All right. Now we have to clean this up. So the negative gets dumped in here. So I get 2xy plus minus 2y dy times x plus. All right. So obviously these, you have to be careful with your signs, collecting like terms, all that kind of stuff. What am I going to do? Sorry? What am I trying to solve for? Dy dx. So get everything that doesn't have a dy dx attached to it to the other side. So this y squared could be moved over, as can this 2xy. So I'll get equals negative y squared minus 2xy. Oh, you know what I didn't do? Anybody see my mistake? This negative, it should flip that sign, right? So that which means negative because this goes there and there. So when I move that to the other side, it becomes positive. There we go. Oscar. Yeah. Yeah, because it's all just being multiplied, so. All right, are we good so far? Okay, what's my next step? Factor out a dy dx from this side here. Final step. Divide it off, right? That is your derivative. And if they ask you to find the slope at a certain point, you just plug it into x and y and it spits out the answer. Okay? Is that okay? It gets a little messy. There's a lot of letters going on there, not a lot of numbers. But you just have to be careful with it. All right. Page 145, numbers 1 to 9, odd, please.